A mason jar sits on a windowsill. Inside it, tiny white roots curl through a tangle of pale green shoots. Warm light, water beads on the glass. It looks like nothing could possibly go wrong in there. That's exactly the problem. Over the next 20 minutes, we're going to look at what's actually happening inside that jar. The real biochemistry that makes a 3-day-old sprout more nutritious than the vegetable it grows into, verified against the actual research. But we're also going to look at something almost no gardening channel mentions. The same warmth and moisture that makes sprouts nutritionally powerful is also the exact environment food safety agencies have spent 30 years warning people about. Both things are true. By the end, you'll know how to get the real benefit without the real risk.
In the early 1990s, a jar very much like this one sat in kitchens across the United States, part of a health food wave that made alfalfa sprouts a symbol of clean eating. Within a few years, that same jar was at the center of multiple multi-state foodborne illness investigations. Nothing about the sprout had changed. What changed was that the public health system finally connected the outbreaks to the growing method itself. Not the seed, not the eater, the environment. That single discovery reshaped how food safety agencies think about sprouts to this day. And it's the thread we're going to follow through this whole story.
Chapter 1. The Countertop Miracle. It's easy to see why sprouts became a symbol of home health. A tablespoon of seeds, a jar, a few days of rinsing, and you have fresh, living food that no supply chain touched. No pesticide schedule, no refrigerated truck, no plastic clamshell. Compared to a $40 bottle of supplement capsules, a jar of mung bean sprouts costs pennies and takes less time to grow than it takes for an Amazon package to arrive. But cheap and simple isn't the same claim as nutritionally superior, and that's where a lot of sprouting content quietly starts to slide from biochemistry into marketing. So before we get to any specific sprout, we need to answer a more basic question. What is actually happening mechanically inside a soaking seed? To answer that, we have to shrink down, past the mason jar, past the seed coat, into the cell. Chapter 2. The Real Chemistry of Sprouting. A dry seed is not asleep. It's paused. Everything the future plant needs is already packed inside it. Starches, proteins, fats, but locked behind a chemical gate. That gate exists for a reason. Seeds contain compounds like phytic acid and certain enzyme inhibitors that block premature germination, and, as a side effect, also make some of the seed's minerals harder for a human digestive system to absorb. Add water, and the gate opens. Enzymes that were dormant activate. The seed begins converting stored starch into simple sugars, stored protein into free amino acids, and, critically, begins breaking down a meaningful share of that phytic acid. This is the actual, measurable reason sprouted foods are frequently easier to digest and better absorbed than their dry counterparts. Not magic, enzyme activation. At the same time, the seed starts synthesizing new compounds it didn't have before, including a real, measurable rise in vitamin C content in many species, because vitamin C synthesis is part of what an actively growing plant does. This is well established in plant physiology research and isn't seriously contested. It's one of the few sprouting claims that holds up completely. So far, that's genuinely good news. But notice what that same paragraph implies. An actively growing organism sitting in water at womb temperature. That's not just ideal for a plant embryo. It's also ideal for something else. Here's the detail almost no sprouting video mentions. Bacteria thrive under the exact same 3 conditions a sprouting seed needs: warmth, moisture, and time.
A seed's outer coat can carry bacteria that survive the growing conditions in the field, and once that seed is soaked and kept damp at room temperature for several days, any bacteria present has the same open door to multiply that the seed's own enzymes do. This isn't a fringe theory. It's the documented reason public health agencies in the United States have specifically and repeatedly warned about raw sprouts. Not sprouts grown in a lab, not a hypothetical, actual multi-state outbreaks traced to alfalfa, clover, mung bean, and other raw sprouts over multiple decades.
Current FDA guidance recommends that children, older adults, pregnant people, and anyone with a weakened immune system avoid eating raw or lightly cooked sprouts entirely, and recommends everyone else follow specific safe growing and rinsing practices. That's not a reason to abandon sprouting. It's a reason to do it correctly, and almost nobody making a sprouting video tells you what correctly actually means. We're going to. Chapter 3: The Sulforaphane Story. Testing the biggest claim. If you've watched more than one sprouting video, you've probably heard some version of the claim that broccoli sprouts contain dramatically more of a compound called sulforaphane than mature broccoli. That specific comparison traces back to research from Johns Hopkins, most associated with researcher Paul Talalay, who studied how young broccoli sprouts concentrate glucoraphanin, the precursor compound that converts into sulforaphane when the plant tissue is chewed or crushed. Here's the honest version of that story. The concentration difference between young sprouts and mature broccoli is real and well documented in the original research. What deserves more caution is the leap from concentrated compound in a plant to proven cancer-fighting food, a leap a lot of home sprouting videos make in a single breath. The laboratory and animal research on sulforaphane's effect on detoxification enzyme pathways is genuinely promising and worth knowing about. Large-scale human clinical evidence that eating broccoli sprouts prevents cancer is, as of today, still an active area of research rather than a settled conclusion. That distinction matters. A viewer who hears cancer fighting and stops eating vegetables for 6 months waiting for a miracle is being done a disservice by a story that skipped the caveat. A viewer who understands promising, mechanistically plausible, still being studied, walks away with something more useful, a genuine reason to add a good vegetable to their diet, sized correctly. Once you start asking, what does the evidence actually say about one claim, it's hard to stop. So let's run the same audit on a few more. Chapter 4: The Myth Audit. Take the claim that a specific leafy sprout contains more vitamin C, gram for gram, than an orange. For several sprout varieties, this comparison is defensible. Vitamin C concentration genuinely can be higher in a small, actively growing shoot than in the water-heavy flesh of a citrus fruit. But gram for gram is doing a lot of work in that sentence. Nobody eats 100 grams of garden cress in one sitting the way they'd eat an orange. So the practical vitamin C delivered in a typical serving tells a more modest story than the headline comparison implies. Or take wheatgrass, often described as a concentrated source of enzymes and nutrients that outperforms almost anything else on a counter. The chlorophyll and micronutrient content of fresh wheatgrass juice is real. The claim that it delivers dramatically superior nutrition compared to simply eating vegetables doesn't hold up as well under scrutiny. Much of wheatgrass's traditional reputation predates the kind of controlled research that would actually test those specific claims. None of this means the underlying foods are bad. It means the marketing language around them consistently runs ahead of the evidence, and a genuinely useful video should be willing to say so. Chapter 5: Growing Sprouts Safely, the Practical Application. So what does a safety-conscious sprouting practice actually look like? It comes down to controlling the 3 conditions bacteria need without eliminating the conditions the seed needs. Start with seed sourcing. Buy seeds specifically labeled for sprouting, not seeds intended for planting in soil which are treated differently and not food safety tested. Rinse thoroughly before the initial soak. During growing, rinse and fully drain at least twice a day without exception.
Standing water is the single biggest controllable risk factor because it gives any bacteria present a stable place to multiply rather than being flushed away. Keep sprouts at room temperature rather than somewhere warm, like near a stove or in direct sun, since higher temperatures accelerate bacterial growth faster than they accelerate the plant's own development. Use clean equipment every time, and once harvested, refrigerate promptly and eat within a few days. And the honest caveat the whole video has been building toward: if you are pregnant, elderly, very young, or immunocompromised, current public health guidance is to skip raw sprouts entirely and cook them thoroughly if you eat them at all, since cooking is the one step that reliably eliminates the bacterial risk that rinsing alone can't fully guarantee. That's not fear-mongering. That's the same category of routine, practical guidance as cook chicken to a safe internal temperature, a known risk with a known manageable solution. With both halves of the picture in view, the real nutritional upside and the real manageable risk, we can finally answer the question this video opened with.
Chapter 6. Building an Informed Sprouting Practice. If you want to start, the strongest evidence and the most forgiving safety margins point toward a small starting set: mung bean sprouts, because they're the most extensively studied and most digestion-friendly entry point; broccoli sprouts, because the sulforaphane research, properly framed, is genuinely one of the more interesting stories in home nutrition; and pea shoots, which carry real vitamin content, a flavor almost everyone likes, and, because they're grown in soil rather than a wet jar, a somewhat lower bacterial risk profile than jar-sprouted legumes. From there, the enzyme-driven digestibility benefit, the real vitamin C increase, and the documented bioactive compounds in sprouts like broccoli and radish are all reasons to keep a rotation going, as long as the twice-daily rinse and proper storage become as automatic as the soaking step everyone already remembers.
That jar on the windowsill isn't magic, and it isn't a trap. It's a small, fast, biochemical process you can actually understand. And once you understand both halves of it, you're not following a trend. You're running a kitchen experiment with the instructions included. If you're starting your first jar tonight, don't just soak the seeds. Grab our free companion sprouting safety checklist linked below, so the rinse schedule and storage steps are somewhere you'll actually see them at day 3, not just today. We'll be back next week with another Evergreen Garden documentary. Same standard, real mechanism, real sourcing, no shortcuts on the parts that matter. See you then.